Hello learners, in the last video we have discussed about the introduction and the definition of the linear transform of a function. If you want to know the introduction and the definition of the Laplace transform of a function, you can check the link which I have provided in the description box. Today in this video we are going to learn about the linearity property of Laplace transform. So let me write the statement of it. It is one of the important property of the Laplace transform which we will use in further session also. If f of x and g of x are if f of x and g of x are two functions whose Laplace transform whose Laplace transform of exists, and if small a and small b are any constants then the Laplace transform of a of f of x plus b of g of x, that is equals to it's a of Laplace transform of f of x plus b of Laplace transform of g of x. So what is there in the statement? If f of x and g of x are any two function, it means that they are obviously the real valued function, because we define the Laplace transform on a real valued function, and a and b are any two constant. But what is the actual meaning of this statement? The meaning of the statement is that the Laplace transform of addition of two functions, the Laplace transform of addition of two function is equals to the addition of their Laplace transform. That is the addition of their Laplace transform. So let me prove this one. So what they have given not the given. As in the statement as in the statement f of x and g of x are two functions whose Laplace transform exists. It means that the Laplace transform of f of x, that is equals to 0 to infinity e raised to minus of sx f of x dx exists, and the Laplace transform of g of x 0 to infinity e raised to minus of sx g of x dx exists means it has some definite value. Uh, value definite value definite value um, by the by the definition of Laplace transform Laplace transform by the definition of Laplace transform L of a of f of x plus b of g of x, it will be 0 to infinity e raised to minus of sx the a of f of x plus b of g of x dx. So why? Since we know that since the Laplace transform of f of x that is equal to 0 to infinity e raised to minus of sx f of x dx. Here you can see, here it is f of x, so it is f of x. Here the a plus f of x plus b into g of x, that's why here here that is a into f of x plus b into g of x. And here you can see that if we multiply any constant to a real valued function, it will be again a real valued function, and the addition of the two real valued function, it will be again a real valued function. So hence we can define the Laplace operator on this real valued function. I want to say that this a plus a into f of x plus b into g of x, it will be a real valued function. It will be again a real valued function. So this L of it's a of f of x plus f of x plus this is b of that is the g of x. It will be, this is 0 to infinity, 0 to infinity e raised to minus of x ax, that is the a into that is the f of x plus b into that is the g of x dx. Dx. So let me multiply this one. So this will be 0 to infinity, it will be the 0 to infinity, it's a of e raised to minus of sx f of x plus b into e raised to minus of sx g of x dx. And since we know the property of the integral, that is what is the property of integral, that is the f of x plus g of x, g of x dx, it is equals to equals to that is the definite integral, it is equals to the integral of a to b f of x dx plus integral a to b g of x dx. So by using that property, so we can write this L of a of f of x plus b of g of x, we can write it as it is 0 to infinity, it's a of e raised to minus of sx f of x dx plus it's a 0 to infinity b into e raised to sx g of x dx. So dx, here a and b are constant, so we can take them outside the integral. So it will be the Laplace transform of a of x into b into g of x, that will be it is a 0 to infinity e raised to minus of sx f of x dx plus b into 0 to infinity e raised to minus of sx g of x dx. So that is equals to, it's a of, this is nothing but the definition of Laplace transform of f of x, so this is plus b of the Laplace transform of g of x. So that is the a of that is the f of x plus b into that is the g of x. Hence the proof. So hence the proof. So hence the proof. So learners, if you are having any doubts, please comment me in the comment section, and please don't forget to like, share and subscribe to my channel, because your subscription motivates me to make more educational videos based on mathematics. So please like my channel, share my channel and subscribe my channel. Thank you.